Hello and welcome to this ARA webinar with staff from the Council of Producers and Distributors of Agrochemicals titled Adjuvant Advantage for the Sales Agronomist. Today's webinar, gentlemen, I guess we're supposed to call this episode 2 of season 2, focuses on adjuvant application with pre-emergent herbicides and is sponsored by Ravenza Next and Helena Agri Enterprises. I want to thank both of you for sponsoring today's webinar. My name is Hunter Carpenter. I'm the Senior Director of Public Policy at ARA, and I'll introduce our webinar speakers today in just a bit. But first, I wanted to go over a few things so you know what to expect on today's webinar. First, thank you again for taking time to be with us today. Webinars are an important part of the ARA professional development pathway, and they provide a great opportunity for ARA member companies to help educate their employees. Questions will be addressed at the end of the presentation, but you can type them at any point into the chat panel or the Q&A function. And today's webinar will be recorded, and the recording will be added to the member-only ARA dashboard section of the website and on our YouTube channel. As a reminder, you can log into the ARA member-only dashboard at any time to access past webinar recordings on sustainability services, data trends and conservation, and much, much more. If you have any idea on how to get an ARA login or don't have one, you can email info@aradc.org to set one up. You'll also be able to scan a QR code at the conclusion of the webinar and receive 1 IPM CEU credit for your Certified Crop Advisor certification. So with that out of the way, I'm excited to introduce our 2 speakers, Johnny Roberts, Director of Education, Adjuvant Chemistry at CPDA, and Joe Janowski, Director of Education for Adjuvant Development at CPDA. Johnny has 45 years of experience in the development and technical support of pesticide, fertilizer, and adjuvant formulation. 44 of those years were spent with Helena Agri Enterprises. Johnny is also the co-inventor of 15 U.S. patents related to pesticide, adjuvant, and nutritional formulations. Joe has over 40 years of experience in the development of adjuvants and spray application technology. 35 of those years were with the legacy Winfield United companies. He also holds 41 U.S. and international patents on the composition of new agricultural adjuvants, wind tunnel design, and application technology. He's the author of numerous scientific publications on these topics. And so now I'm going to turn it over to Joe for some background on why today's webinar is so important and why CPDA has chosen adjuvant application with pre-emergent herbicides as today's focus. So Joe, I'm going to turn it over to you.
Thank you much, Hunter, and good morning or afternoon, depending on where you're at. We're excited about today's webinar, particularly because it's a new space that's been there forever, and we've really never developed it in the row crop market well. And so we're hoping to try and lead you in that direction and discuss some of the reasons why you should at least look at it. But one of the other important topics that we'd really like you to pass all the way down to your growers is about the Endangered Species Act. The EPA has been working on this for a long time. They're going to make another run at it again. They really want to try and put 150-foot buffer zones on virtually every pesticide application in the U.S. Is what the fear is. And these will be on the pesticide labels, certainly on any new ones, and then on any re-registrations, or they can enact them on existing. So what CPDA and ARA are really trying to do is look at ways to mitigate these measures. And one of those is to use drift and deposition adjuvants. These soil applied adjuvants also, when it comes to water movement in the soil, can also be beneficial. So, but this is bring this to the attention of your growers that they need to work through their commodity groups, through ARA, to really try and make sure it's clear that these large buffer zones would be a huge detriment to U.S. agriculture. Next slide, please. And what we're really trying to do from ARA-CPDA is to focus on being able to discuss with the EPA about using adjuvants to mitigate this. So it would be one thing that you, as a retailer or custom applicator, could do is potentially mitigate the amount of that buffer zone by using a drift reduction agent that we hope will be on the list of things that can do that. They've already set a precedent with Enlist and dicamba technologies showing that drift and deposition agents can reduce the buffer zones. And so we're hoping to carry that on into the overall market, that we can use these to reduce off-target movement. Next slide, please. So we think this is the right approach. They propose a menu of mitigation efforts at the agency, and we're working hard to add drift and deposition agents and to reduce spray drift and surface water runoff of pesticides. We know how to do these things. We just have to get that message passed on, and we really appreciate you voicing this with your growers, how important this is to be active in this at their local level. Next slide, please. We want to thank our advisory group that helps us on all of these, looking at our content that we're putting out, advising us on the next webinars that we do. So we really appreciate the people at Growmark, Helena, Nutrient, Invictus, Simplot, and Wilbur Ellis helping us on these. Next slide, please. This is approved for continuing education credits, and at the end of the presentation, we will show that QR code that you can scan to get your credits if you're a certified crop advisor or certified professional agronomist. Next slide, please. So pesticide labels have rarely recommended adjuvants in the past. In 1976, only 3 pesticide labels recommended using a spray adjuvant. Today, that's grown to over 2,000 or more that do that. So we've made an impact, and I just want to address that spray adjuvants are an important part of a successful spray application. Next slide, please. So this is, if you want to go back and review last year's webinars, we covered all of these areas in specific webinars, talking about the enhancers of surfactants, crop oils, methylated seed oils, activators, high-load surfactants. We've talked in the previous one about compatibility agents and foam control. We've had one also on the use of drift and deposition aids. So all of those former webinars are on the website at both CPDA and on ARA. So please, if you missed any of them, they're sitting there on a rainy or snowy day, you want to go get a little more education, you can take a look. Next slide, please. So the one we're talking about today is adjuvant applications with pre-emergent herbicides. Because of resistant weeds, the pre-emergent market is increasing tremendously. We know there's variable impacts on efficacy due to weather, primarily lack of moisture. And today we're going to look at, can adjuvants help reduce that variableness? And so the next thing I'm going to do is turn this over to Johnny Roberts and let him get into the intent of the webinar.
Okay, thank you, Joe. Next slide, please. These are the resources I'll be leveraging off of today. They're excellent background on managing these variables that Joe referred to. Of particular interest is the Weed Science Society of America's monograph on adjuvants for herbicides. They have a chapter specifically that deals with the fate of adjuvants in soils. So if any of you would like to follow up on any of these subjects that I'll be talking about today, those are the good references to do so. Next slide, please. And as Joe indicated, the biggest reason we're seeing such a renewed interest in pre-emergent herbicides is in the weed resistance management piece. I mean, it's really as we learned actually many, many years ago, controlling these weeds before they've had a chance to reproduce is the best way to manage any kind of future resistance. So we're going back to that, and particularly as we get resistance problems with our post-applied materials. And more, you're seeing joint applications of these herbicides with liquid fertilizer, and that's being done as we need to get them out earlier to prevent the fertilizer loss that weeds are consuming. And then they also give you the option of longer term weed control with the potential to actually have lower application costs. So even though with very few cases, most of them are very old, established chemistries, it's sort of back to the future, and we're going to see more and more of them in the near future. Next slide, please. Those of us who've dealt with them know that they have the most variable performance, or can have, of any of the herbicides that we deal with. And any of us can, through our experience, knows that you can go 5, 6, 7 years out of those periods, same herbicide, same piece of ground, and it works great for 2 years, kind of works the third, doesn't work at all the fourth, and then back to working great. And this is due to the problem we have of trying to farm outdoors, right? I mean, we have so many variables that we're having to manage. Some of these active ingredients are not very stable in sunlight. Some of them volatilize. Stubble can intercept the spray deposits and keep them from getting to where they need to be. There's issues with them leaching and percolating. And then when you consider that in the United States alone, there's over 70,000 types of soil, you can see what a moving target it becomes in trying to manage these variables. Next slide, please. The three that we're going to be most concerned with today is the water repellency aspects of a lot of these soils. Some of them are extremely water repelling, and this would, of course, impact any kind of uniform distribution that you're hoping to get, interacting with or slowing down the absorption and so on. Another problem is sunlight. We have a number of these active ingredients that are not stable in sun, and we have to get them off the top of the surface and down below. And then we have the issue of rainfall or irrigation water reducing the retention of some herbicide actives, and losing this retention or gaining too much of it can be an issue when it comes to efficacy and crop injury. And what our goal is today is to point out how adjuvants may have a role and provide the option of another tool in reducing the negative impact from these three specific variables. Next slide, please. The one that is the most obvious, and really, if you look at this whole picture of using adjuvants with soil applied pesticides, and that's in the issue of water, is a very poor carrier when it comes to depositing on a soil surface. It has a tendency to bounce off. It has a tendency to not wet. It has a tendency to evaporate. And all of these are well-established problems, known problems, and adjuvants have had a role in offsetting this for quite a few years. Next slide, please. What makes these soils water repellent? Some of them can be extremely, we use the term hydrophobic. I mean, water literally beads up, has no tendency to migrate down. This repellency is typically due to organic matter, low clay content, when you get less than 5%, and when you have the impact of fire or burning or those type of things. All this has a tendency to make these soils very water repellent. And when you have difficult to wet soils, you're going to get uneven wetting and coverage of any crop input that you apply in a water-based spray. Next slide, please. So adjuvants can improve the deposition characteristics of water on soil, and they do this by stopping spray droplet bounce. There are applications out there where bounce of the herbicide and a lay-by application, for example, hits the underside of leaves and causes injury. Adjuvants have been used to minimize that for quite a few years. Some of them will increase the speed and degree that water spreads and wets, which is an important factor for something we're going to be talking about here shortly. And then reducing evaporation is a big issue. If we can slow down the loss of water in these water-based sprays after they've been applied, that helps in the overall goal of what we're trying to do here, which is to wet the soil and then actually be absorbed directly into it. And the one that we're going to focus on is how we can enhance the amount and speed that water is taken up and why this is an issue of concern and something we want to do. Next slide, please. These features that we just discussed about are all due to the ability of adjuvants to reduce the surface tension of water. And we've discussed about this at length in other seminars, this tendency of water to hold on to itself and not adhere to anything else. And so if we reduce that surface tension, we get increased coverage and wetting. We can get increased absorption and adsorption of some actives on the soil particles. And then we get this faster rate of penetration to the soil. And the reason this is such an issue and is such importance is the faster we can get this into the soil, the less time that active ingredient is exposed to sunlight. Next slide, please. Sunlight is detrimental to the stability of several important herbicide active ingredients. I've listed the ones up here that are the most common and most researched. Trifluralin, pendimethalin, sulfentrazone, metribuzin, all these have an issue of if you don't get them incorporated, if you don't get a rain event pushing them down, they are subject to decomposition by sunlight. And a lot of formulation chemists have worked on this problem over the years. Lots of research done, on, for example, on trifluralin, trying to come up with various UV inhibitors, some sort of formulation ingredient to reduce the negative impact of UV light. And none of these have really turned out to be cost-effective solutions. So the options out there for anything that's sort of a UV protectant that is economical for use are very few. There's a few out on the market, but something that directly reduces photodegradation is not a good tool, not one readily available. A tool that is available is how we can offset this photodegradation indirectly. So obviously anything that gets those active ingredients off the top part of the soil and in such a way it's done in a quicker and greater amount is positive in protecting actives from UV light degradation. Next slide, please. So some general guidelines when we're looking for an adjuvant to enhance coverage and penetration of herbicides on soil. As we learned in previous webinars, non-ionic surfactants are the surfactants of choice. They having no net ionic charge, they tend to mix better. They tend to not be absorbed by the soil, which can oftentimes have its own set of charges. So a surfactant ingredient with no charge is obviously the best in terms of getting through an environment like that. They have also, as a general rule, much better margins of crop safety. So that's your first guideline. In terms of use rate, this can be quite variable. The use rates of commercial products range from 0.05 to 0.25% by volume, or 5 to 32 ounces per 100. That rate depends on the type of adjuvant it is, the type of surfactant that is being used, all those things. So it can be quite substantial. And as you would imagine, if you have higher volumes of water, you would need less of the particular adjuvant. The rate tends to be lower. With higher volumes, that's the case, but with lower volumes, you tend to use higher ones. A lot of these soils have a lot of variability in their water repellency. Some of them may, in one particular year, may be very water repellent. Growers have some interesting ways of measuring that. Oftentimes it's based on how dirty their boots get when they walk across a muddy field. But it is something that varies, and the more repellent it becomes, obviously, the higher rate you would have to use. And the other thing is to keep in mind is that when you're using liquid fertilizers along with this herbicides in one mix, a compatibility agent needs to be considered, and particularly if it's an oil-based adjuvant. Next slide, please. So the next issue, and it's the one by far that is the most complex, the one that we are still learning as we go, but it's of great interest in that if we can use or have access to a tool that helps us impact the actual availability of the herbicide once it's in the soil. So once we get it off the top, we have another whole set of variables to deal with that can impact the availability and also even the crop safety. And so availability is impacted by soil type, rate, rainfall, the time of season, even the amount of crop stubble that is in the field before you apply the herbicide. And these variables are addressed as a commonly on the labels by variations in both rate, application timing, the incorporation method. Oftentimes there are use restrictions based on irrigation and water events. But what we'll be talking about is how spray adjuvants may also be a tool to actually impact this availability issue. And there's two goals here, and they're almost kind of counterintuitive. You know, we want to hold materials, but we also want them to move to where they're available in the uh, weed germination zone, but at the same time, not move to places where they can cause an issue with crop safety. So it's a real Goldilocks spot. And, you know, once you find that, it can be quite dramatic, the impact that it can have on both safety, crop safety, and efficacy. Next slide, please. So the best way to anticipate whether or not a given adjuvant is going to have some sort of positive impact on a pre-emergent herbicide, you can rank these herbicides and look at them by their degree of oil solubility versus their degree of water solubility. The more oil soluble they are, they tend to be bound tightly to both the soil and organic matter. The more water soluble they are, they tend to move quickly with water, leach quite dramatically. And so you can have the range of just essentially non-mobile in the case of pendimethalin when it comes to water to very soluble when we have something like clopyrrolid. Now, the thing to keep in mind here is even those materials that are uh, poorly soluble in water, something like pendimethalin, trifluoralin, those, they still move with the water. If they didn't, they wouldn't be effective. So there is some movement. And again, finding that spot between some movement and too much is what our goal is in this case. One thing that variable that comes into play is soil organic matter. As you can imagine, this organic matter tends to be very oil loving. It tends to hold on to oil soluble materials. And in that particular case, you know, the ability to change or mitigate that with an adjuvant becomes much more difficult. While those with some higher degree of water solubility, you can have more direct impact. Next slide, please. So if we're going to consider an adjuvant for use and looking for the goal of retaining that active ingredient in the soil, and again, this retention word doesn't mean that we're going to hold it there indefinitely. If we did, we could cause another whole range of issues. We don't. But just to impact in some way the movement of that herbicide and the eventual holding of it. So as a general rule, high oil solubility herbicides mixed with oil-based adjuvants tend to be retained in the soil profile where weed seeds are germinating. And crop injury potential is also minimized. There is a well-established, well-known use of using oil-based adjuvants in sandy soils with low organic matter with things like metribuzin, not with the intent of making that metribuzin more efficacious, but with the intent of keeping it out of the root zone and causing crop injury. So that one is a good example of matching oil solubility with oil-based adjuvants. Then when you have the other extreme, herbicides with high water solubility that are really leaching out of coarse soils, low organic matter content. There have been adjuvant systems used in the past based on resins and polymers that actually have the ability to enhance adherence. They're not depending on any solubility issue. They're actually sticking or putting them in a film in some form or fashion. Next slide, please. So the general guidelines, if we're going to look at an adjuvant to enhance retention of soil-applied herbicides, use oil-based formulations for herbicides with high oil solubility. Look at resin and polymer type adjuvants for highly soluble ones. If you have a soil with high organic matter, and for this purposes, we're going to define it as those greater than 4%, you would expect the addition of an adjuvant having the least response in that scenario. In many ways, the organic matter is the adjuvant in terms of holding on to that herbicide. Keep in mind, however, that typically these high organic matter soils also tend to be the most water repellent. And so your goal might switch to one of retention to actually wetting in that particular case. Another guideline to keep in mind, a lot of these pre-emergent herbicides are formulated as WDGs and suspension concentrates. And unless you're directed differently by the label, fully disperse these materials in water or liquid fertilizer before adding any adjuvant, particularly when it's oil-based adjuvants. This is a common source of incompatibility when you have these dry herbicides not fully dispersed before you add the oil-based adjuvant. And as we are doing so more and more commonly, if the herbicide mix contains a liquid fertilizer, then we strongly recommend the addition of a compatibility agent. Next slide, please. So this is an issue where you'll find a lot of established already adjuvant applications. It's a lot more studied, a lot more familiar with, and that's where we have a spray compatibility issue. And if you think they're getting worse, that's because they are. We tend to have lower spray volumes. We tend to have higher agitation speeds. We have more SC formulations. We tend to mix them more with liquid fertilizer. All those things together compound our mixing problems. Liquid fertilizers are of particular concern. And you'll find a number of herbicide labels that will recommend or even require the use of a spray mix compatibility and oftentimes a foam control agent as well. Next slide, please. As we learned in the last seminar about using compatibility agents, there's some guidelines here that if we follow, they're a much more effective tool. Typical use rates can range from as low as 1 pint per 100 to as high as 4 and 5. Keep in mind that they're much more effective as a preventative, and your option of using that lower rate is much more available if you prevent a problem than it is of trying to cure one. The other rule is if you have that fertilizer in the mixture, add the compatibility agent to the fertilizer before adding any pesticides. And if you do get into a situation where the incompatibility shows up after the fact, those tend to require higher rates of compatibility agent and also require agitation. So again, we like to stress their use as a preventative rather than a curative. Next slide, please. So foam problems, we just had discussed this one as well. It's such an issue. It's worth discussing again in the context of using adjuvants with pre-emergent herbicides. It's a lot more than being a nuisance. I mean, you get more foam generation impacts your spray calibration, your worker exposure issues go up. Typically, increases any mixing problems that you're having. If there's a bunch of foam in the tank, it gets that much more difficult to get a complete mixture. Coverage is reduced, drift potentials increase. And so these problems are increasing, and we don't expect them to really get better anytime soon. So using foam reduction adjuvants goes a long way to minimizing these well-known problems. Next slide, please. With these and some general guidelines, and when we're in a soil herbicide application environment, your oil-based adjuvants tend to prevent or mitigate foam formation, some better than others. If compared to those adjuvants that are surfactants only, you will tend to have more of a foam issue. There are starting to be commercial adjuvant products that actually have the foaming agent incorporated with them. These could be useful as well in allowing you to get the benefits of the surfactant without the negative part of the foam generation. And be aware that for whatever reason, when you do get a liquid fertilizer herbicide incompatibility, they tend to be the most difficult to control in terms of foam. I don't really know the reason for that. It may just be that you're adding some viscosity and some body to the spray mix and just makes the bubbles that more difficult to control. But be aware that you may wind up having to use a little bit more when we have a combination of liquid fertilizer. Use rates can be low as 1/2 of an ounce per 100 gallons of water. Keep in mind that that low use rate is an option when you're using it first. In other words, put it into the water before you ever add the herbicides, and you'll have much better foam control. I know it's not as much fun as knocking the foam down after the fact, but they work much better as preventatives than they do as curatives. Next slide, please. So with this particular group, you're going to meet customer objections. And there's a couple of very good reasons for that. Keep in mind that with very few exceptions, herbicide labels have no recommendations for spray adjuvants other than compatibility ones. And it has a lot to do with the newness of this use, the wide variability and variables that we're trying to control. So what are the objections? Well, the first one you tend to get is that if they really needed it, they'd be built into the herbicide formulation. And yes, that is a goal. I mean, there's from the formulation side, you'll find a lot of recent attempts to build adjuvant systems in to make them more compatible, to make them have more of an effect. But we run into the problem with the variabilities and spray mixtures, and soil types. It becomes very difficult to control all those with a fixed in-can rate of an adjuvant. So adding them tank side allows us to vary and handle the conditions that we tend to vary as a applicator. Another common will be, well, look, I've never had performance issues before with this particular application. These ag input formulations are subject to change. They don't necessarily remain constant year after year. Environmental conditions are obviously subject to change. Just because you've not had an issue doesn't mean that you won't have one in the future. These materials are tools to be considered when you've had these variable degrees of performance and application. And a good question is, well, then how do I know if I even need them? And the issue there is, and at the end of the day, we're talking about improved deposition, and that is a goal for a lot of good reasons. Improving deposition is how we manage our worker safety issues, our drift issues, our economic issues, keeping more of it on target. And that is our goal with using these adjuvants in this particular applications. We're just trying to keep more where it's intended and meant to be. And of course, the cost. You're at a sensitive time. You're adding another cost, and it's just too much. It's one more variable. And our argument there is maximizing efficacy is always going to be cheaper than the cost of resprays and application problems. And oftentimes, a lot of what we're trying to do is avoid just having to do resprays and all the grief that comes with actual application problems. Next slide, please.
So Johnny, I would add one thing to your list here is I think our industry has done a very poor job of really working out the benefits of this for soil applied herbicides, and yet you go to the turf market and these soil wetters are commonly used, and if you go to a lot of the hilled crops, potatoes for example, they're almost used once or twice a year to increase getting their fertilizer into those hills. And I think because of the high cost of those markets, we've tended to avoid the regular row crop market, where I do think there's some real opportunities in this. And it may be, an agronomist at a particular retail location that's struggling with performance of soil applied herbicides, go to a couple of your distributors and get some ideas on what to try in there. In today's world, most of the research is done on the farm, evaluating it by individual agronomists, both by observations and yield monitors. And I think this is a good space where we've got lower cost materials that should work in this space. We just haven't done a very good job of addressing it in the row crop.
That's a good point. It reminds you, us old timers that have been around. I can remember a day when we were lacking good knowledge and research on the post-applied use of adjuvants. And, oftentimes, as we've seen in these adjuvant applications, the application is found and the need is demonstrated, but the science comes a little bit later. And we're probably at that point where this is something that's been overlooked. It's a great place to be investigating, new technologies and learning how to use existing ones. So it's exciting, and from the standpoint of it could be one of the last frontiers in terms of finding new uses. And you're right about and it's really ironic. Most of the time, what's discovered and developed on the ag side sort of filters down to the turf side. And in this particular case, the turf guys are ahead of the ag ones. Very good. Next slide, please. So what does all this mean? And the thing we're wanting to stress is that this is an overlooked tool. These variables that have plagued the use of pre-emergent herbicide use have been with us since we've had pre-emergent herbicides. So we need another tool, another option to improve efficacy and application. And so the question on when should I use them, consider them in any of these applications where it's been inconsistent or you have to fight a mixing or application problem every season. Another guideline, and it's an important one to follow, is that unlike the post-applied herbicides, you don't have much in the way of label guidance on using adjuvants. So the adjuvant supplier should share the results of their field application trials and/or their commercial experience. We're modifying. We're trying to improve or change the ability of that active ingredient to be in a certain place. That always brings up concerns and issues about crop injury or performance. So it's important that the supplier of the adjuvant provide their commercial experience or field application trials for that particular use. And when it comes to the application problems, I mean, we've gone past the point of just recommending it. It should be a requirement. If it is a safe bet that if you're going to mix one of these materials in water, we're going to get foam, and foam is problematic for the reasons that I talked about. And if you do have a spray mix that includes liquid fertilizer, a compatibility agent is recommended. And as we learned earlier, have it in as a preventative rather than a curative. Next slide, please. And here is where you can get your credits. And I guess we'll let that set for a while.
Yeah, well, thank you so much, both of you, for a great presentation today. We're going to start with questions posed in the chat and the Q&A function, so you can pose your questions in either application there, and we'll be happy to answer them. The first question, for the adjuvants that enhance adherence to the soil, can they counter impact those herbicides in drought conditions?
Yes, they can, and that's probably one of the reasons they are not used widely. The applications I know of them are very specialized. It's a condition, a soil type that is consistent, because you do get into this issue if you glue them onto a soil surface. You may offset one problem, but then cause another if that herbicide active can't move to where it's supposed to be. And so that again is back to the importance of data and commercial experience if you're going to use an adjuvant for that purpose.
Any other questions? Feel free to ask those now. The next question, research has shown that good pre-emerge adjuvants can extend herbicide control past 30 to 45 days compared to not adding a good adjuvant. Is that your experience?
Yes, I have seen amazing extensions like that, and yeah, and then I've seen others where the impact was not as dramatic. And again, it gets to the variability of the soil types. And back to Joe's observation, I mean, there's so much of the use of these materials for this purpose that are going to be locally generated, because we have so many variables in soil type. If you do a research on this in the literature, you'll find some really amazing stuff about how various adjuvants have enhanced and extended the activity of various herbicides. And then you'll find a counter to that. And again, a lot of it is not understanding the different soil types of that advantage not being there. So yes, it can be quite impressive when you do get one of these Goldilocks spots that the adjuvant gets you in. Another, in my experience, somewhat dramatic impact of an adjuvant on active ingredients is that old issue and we were doing this in the late 70s and early 80s of minimizing crop injury issues from metribuzin in sandy soils. And so, yes, there are some quite impressive results out there, as impressive as some of the post applied, but just not as what's the word, a widespread or understood as they are with the post applied ones.
So what I'd add is, over the years, every time in my former life when I did this for a living, we would address this. The agronomists in the room, the first thing they would throw at us spray and pray guys was, well, wait a minute. There's like 6 gazillion different soil types. I know that's a little high. And how in the world, and a lot of them are in the same field, how are you ever going to do this? And I think that's what kept those of us in distribution from ever actively trying to bring products out. But yes, you can see significant data that shows when used in the right spot, you get a nice return out of this. And I think it's a different world now, and I think we need to readdress this, especially if we can find some lower cost systems that'll work. So it'll work on that hard to wet soil, and you ignore that rest of that field because you didn't waste so much money on it. And I think you got to look at it at a local basis, and I think we can get you some options to what to try in this. So in the past, we simply looked at the known turf soil wetters, which are generally speaking very expensive and not proven to work consistently. And so you got a high cost and inconsistent results, you're not going to do it. But if you got a lower cost, you can stand more inconsistent results.
Thank you. Next question, will there be a significant difference in herbicide soil migration depending on whether it's delivered as an SC versus an EC, et cetera?
I guess you could make the argument if it's an EC, you're going to have that much more surfactant along for the ride, so to speak, and less if you were doing one of the other types. My experience, I've not seen any impact from the formulation differences. Now, of course, you get into something that it's microencapsulated. That's a whole different kettle of fish. But just like, say, for example, the difference between an EC and an SC, I guess you could certainly argue that, and this is one of the reasons ECs, as a general rule, tend to be a little bit more efficacious and easier to apply. You have some surfactants that go along for the ride, but I've not seen it in a case where it's sort of become additive. I guess that's the word I'm looking for. Is just
Yeah, if you want to follow up on that question, please feel free to do so, Trip. The next question is, do oil-based generally work better? MSO any different than COC?
well, it's a good question. I think that is the we're going through a period of of learning about that now. If I had to express an opinion on it, the paraffin oil types, they might hang around a little bit longer, but then you could argue the MSO types would be thinner and more easily moved down. So I don't think we've really established that quite yet.
Any other questions for our presenters today? While folks are thinking about questions, this is probably a great time to let you know once again that today's webinar is sponsored by Ravenza Next and Helen Agra Enterprises. We've partnered with CPDA on this series of webinars. As I said earlier, I kind of joked that this is season 2, but it really is. I mean, we've had now somewhere in the neighborhood of 10 to 12 webinars on these issues. It's been hugely popular with our membership. I'm sure CPDA's membership as well. Great opportunity for folks to receive continuing education. We will continue to have, hopefully, those CEU credits on these webinars. I know that CPDA is looking for sponsors for future webinars. So if you're interested in that, you can email me, hunter@aradc.org, and I'll set you up with the CPDA staff to get that rolling. I also want to let you know about the next webinar scheduled for January 11th at 1 p.m. Eastern, sponsored by Exacto and Invictus. This will be focused on adjuvants and drone applications. So very pertinent and timely information there as we move into a new season with new technologies. We're all very excited to have these discussions. Wanted to let the folks with CPDA jump in if they have anything to say or add before we get going. I will remind you this webinar is being recorded, and we will post it to ARA's member portal and also our YouTube channel, and also give anyone that has another question time to ask that. So if anyone, Johnny, Joe, I know Terry's on, if you have anything to add from your end, we'll give folks just a couple seconds to ask additional questions. I'll put the CEU credit QR code back up, and we'll go from there.
If no other questions, thank you very much.
We just got one.
Okay,
will polymer-based adjuvants stay longer in the soil versus oil-based adjuvants?
Of course, it's going to depend on what the polymer is. Obviously, if you get a sticky, tackier, heavier molecular weight polymer, I could make a venture as a guess, it would hang around longer, yes. And of course, we're looking for that Goldilocks spot of hanging around longer is not the end game here. Hanging around longer and still being available for control of the weeds is what we're trying to get at. But yes, the bigger the polymer, I would think the longer you could hold that material in place.
All right, we'll see no additional questions. Johnny, Joe, want to thank you both again for a terrific presentation. We look forward to talking with you in January in the new year. So until then, everyone have a Merry Christmas and Happy Holidays, and we look forward to speaking with you again in just around a month from now. So thank you again for being on. Have a good day.
Thank you.
Thank you.